Hi everyone. In the problem statement of LRU Cache, design a data structure that follows the constraint of least recently used or LRU Cache. Here we are going to have an int capacity initializes an LRU cache with an positive capacity. Then we are going to have a function called getIntKey returns the value of the key if the exists, otherwise return -1, and void put with the value of key and the value. Update the value of the key if the key exists, otherwise add the key value pair of the cache if the number of keys exceeds the capacity from the operation evict the least recently used. So in order for us to solve this, we're going to have require a dictionary. We need a stack, and we are going to have an int capacity or an integer value called capacity. For the first case, right, our capacity is 2. Now for the first thing that we are going to put the value in our dictionary. So our dictionary is going to have a value of 1, and in this stack, right, we are adding the value of 1 to our stack. In the second case, we are putting another value. Let us not remove it for now. We are going to create 2 value. Now we are going to get 1. So 1 is present, so we are going to return 1. So first value 1 is going to get returned. Now we are going to put another value, and here right in our stack we also have to add 2. Now when we are going to add that value, right, when you're going to put or let's say when you're going to get putting the value of 3 and 3, right, so in that case, right, our dictionary is already pretty high, right, because our capacity is exceeding. So in order that we are going to remove uh the 2, because when you call the 1, right, so from popping 1 and the 1 came up here, so the 2 was the least recently used, so you're going to remove 2 and the 2 is going to get removed, and we're going to have 3 out here, and the key would be 3 3. Now again get is called, but we do not have to add it, so we are going to return -1 from here. Then put, but because we are adding put, right, so 4 4, but here, right, our is already higher because our capacity of 2, so 1 is the least recently used, so 1 got evicted out, and we can add 4. So now when we try to get 1, so 1 is not there, so we again return -1. When we get 3, so we're going to get 3 and 4. So using these 3 data structures, right, one dictionary, another stack, and another integer variable, we can solve it. So we require a hash map, a stack or an array to store the least recently used, dictionary to store the key value where, and a capacity to make sure that our dictionary or stack does not exceed the capacity. So you have to use it. We have to have a basic understanding of classes in Python. So let us jump for the Python solution for it. So the first thing that we are going to do, we are going to create our variables because it's a class function. So we are creating a class variable. So it would be self.lru, which is going to be our hash map. Then self.capacity, which is going to be our value that we are getting it when we are defining this LRU cache. So capacity, and then self.lru or list or self.recent, which is the least recently used. We're going to get a track of it. Now when you're getting a key, right, you have to return it. So if key in self.lru, in that case we are going to do self.recent dot remove the key that we got. So in case there are any previous instance of the key, it's going to get removed, and then we are going to add or append the key to the last most or the tail of the array. So self dot recent dot append our key. Now we are going to return self dot LRU, and we are going to have our key value. In case the key is not present, right, in that case we're going to return -1. Now for adding the values, right, so if key is already present, then we just need to update our value of the hash map. So if it's present already in LRU, in that case self dot recent dot remove our key, and again self dot recent dot append the same thing that we did for the get, right? We are removing the previous instance of the key from our stack and then adding the latest value to the end of the stack. So same thing that we are going to do, and we are also going to replace the value of the hash map with the current value. So LRU key is equal to the value that we received. But in case, right, the key is not present, in that case elif if the length of self dot LRU dot keys is less, so our capacity, right, the values that are stored in our cache is lower than the capacity that is assigned capacity, so nothing to do. So we are going to do self dot recent dot append, because we know that value is not there, so nothing to worry about. So we're going to append that key, and self dot LRU dot key would be the value. But in case it exceeds the current capacity, then we are going to do rm key equal to self dot recent, or the taking the topmost value, recent 0. We're going to delete that key, so self dot recent 0, and we are going to add self dot recent dot append the key to our list or our stack, and similarly we're going to delete in the hash map also. So self dot LRU rm key, and we're going to add the value to our hash map too. So LRU key equal to value. Now let me run the code. I hope there aren't any spelling errors. As you could see, it got accepted for the first test case, and let me submit the code. I hope it should work. So it's pretty straightforward code in that sense. As you could see, it's beating 6.08. It's funny. But if I look into it, right, it's just the complexity of it is pretty straightforward. It's big O of n. But obviously, there would be some time involved in finding the key and deleting it. I hope, let me run it again, and I hope the performance would improve. Let me check it out. Okay, it's not improving, so maybe there are scope for improvement out here. I'm pretty sure maybe the way we are removing the values from the stack, that could be optimized a bit. Maybe you guys, right, if you have a better solution than this, feel free to add it in the comments. So that will also help me in my own understanding of the problems. So that's all for this video. See you in the next one.